Okay, so we are going to find the relationship between dt and dt prime, and it's not immediately obvious how we can do this. So we have seemingly two alternatives. So do we use? We have to use Lorentz transformations, right? That's given, but we can either use this Lorentz transformations t minus, Vx, or the inverse Lorentz transformations, which is t gamma t prime plus Vx prime. And if you take the derivative of this, it's simply going to give dt prime is gamma times dt, and this is going to give dt equals gamma times dt prime. Right, and both cannot be correct because gamma is not unity. Then you realize, okay, but wait, there's also x here, right? So v is a constant. V is just the speed of one reference frame with respect to the other. It's a constant, but we also have this x and x prime. So we also have to have like gamma dt minus gamma v dx, right? And here gamma dt prime, gamma v dx prime. Now, is either of them 0? Turns out that yes, one of them is 0. This one, x prime is 0. So it's not really 0, but what's happening? I mean, it can't be, right? If this is not 0, if the x is not 0, the x prime cannot be 0 either. But this is going to be second order in dt prime, whereas this is going to be first order in dt. So it's also going to be consequently first order in dt prime, because they are going to be proportional to each other. So what we need to do is to use this one, and because the x prime is just 0, so since the x prime is 0, to first order in dt prime, we can write dt is gamma times dt prime. Right, so then we take this over here. We have Vx is V plus 1 minus V squared A over gamma dt. Now this is already 1 over gamma squared, so this is just V plus A over gamma cube times dt. Okay. And this part is just dvx, so I can rewrite this as dvx by dt, which is the acceleration of this particle in the original unprimed reference frame, is or let's multiply this by gamma cube is equal to a. So the proper acceleration of a particle is given by the acceleration in the inertial reference frame times the cube of the gamma factor. So how can we use this? Well, you can make one manipulation here, which I'm not going to do the details, but you can do this by direct substitution. Gamma as function of Vx, let's say, times Vx is equal to a. So you can write this expression as a total derivative of this, and then you can integrate this equation. What does this give? Well, it gives you gamma times Vx is equal to a times delta t. And if we take our velocity to be 0 at t equals 0, as was given in the problem, with Vx t equals 0 being 0, this gives gamma Vx is a times t. Right? So we can write this expression. So yeah, let's do this. Vx by 1 minus Vx squared square root is a times t. I square both sides. Vx square 1 minus Vx square is a square t square. Take this to the other side. Collect the terms. So Vx square is a square t square 1 minus Vx square. Collect Vx square terms. What do we get? Vx square, there's term. 1 plus a square t square is a square t square. Move this to the denominator, take the square root, we get Vx is at divided by square root of 1 plus a square t square, which is precisely the expression that was given in the previous problem. So we reduce the problem to the previous problem, which we already solved the back page. Alright, so as I said, the solution in the solution manual is very elegant, and in principle that is what you should learn. You should really learn to solve it this way, but hopefully this is more intuitive. This helps you to solve this problem and similar problems. Okay, that's all for now. Thank you.